Okay guys, welcome along. Now we're going to look at the text and text book on page 13, text and text 2. So we'll just jump straight into the examples and exercises. So algebraic division is a lot like numerical division, whereby you want to take something like 17, divide it into, just do a calculation here, on the side. Three, 9, 2, 7. Okay, where you want to know how many times does 17 go into 39, and you get twice, and that leads to 34, which means you're taking away 3400 here, and you're getting 5, bringing it down to 2, bringing it down to 7. And we're going to be doing stuff just like this. 17 into 52 goes 3 times. There's a multiplication coming out this way. You have 17 left, and the answer is 1. Okay, except instead of being 10 to the 4, 10 to the 3, 10 to the 3, 2, 1, and 10 to the 0 or 7, it's x's. So you've got a long division technique. Okay, but a shortcut for long division in certain cases is synthetic division, which I'm going to show you here. You draw a big huge 4, which isn't a 4 at all, and you write 3 coefficients here, if it's cubic, the last one here. And you solve this to be naught, so you convert the factor into a root. Okay, and it seems very daunting at first. You add that to nothing, you multiply here, multiply again, you add, you multiply here, and this tells you the remainder is 0, and it gives you your answer of 2x squared minus 5x plus 2. Now it's not magic, it's just long division kind of made easy, with all the x's gone for a little bit before you get to the end. It's called synthetic division. We won't always use it, but we will use it a bit. Okay, here for example, you'd want to put in a naught where the x squareds are. This would be 2, because x minus 2 equals naught as a root of x equals 2. And your final answer is 4x squared plus 8x plus 3. And I think you'll agree that was pretty quick. Now, when you're doing a quadratic divided by a linear, in school maths, there's never going to be a remainder. In junior cert anyway. So you can just divide the ends. But you might, they could be argued, a teacher could argue, examiner might argue that that's not absolutely definitely true. What if this had been 6 or 7? That wouldn't have been the right answer. Okay, it's only correct because there's no remainder. Well, you can just multiply the x plus 2 by the x plus 3 and make sure it's equal to the middle, and then you've been thorough then. So you get 2x here and 3x here, so you do indeed get x squared plus 5x plus 6. So dividing the ends will work fine. So here the answer is x plus 7, 2x plus 1, 3x plus 1, etc. Now I'm going to skip past a few because they're too easy now. It's just a bit of repetition. So we see something more interesting. I'll just divide the ends. Okay, just divide the ends. 5x plus 4, 3x minus 4, etc. Simple, simple, simple. But now we have a cubic, so you can go with synthetic division. And I'm going to show you another really, really handy trick. If you don't like synthetic division, or if you find it a bit confusing and you're afraid you mightn't get it, you should be able to get it eventually. X squared plus 2x plus 3 is the answer. Okay, but I want to show you another method. So what if you did divide the ends? What would be wrong? Well, you wouldn't have... If you divide the ends, you'd get x squared and 3, but you wouldn't have the bx term. Well, that's okay, we don't have it, but we'll call it bx. But what we do know is when we multiply it by that, we get this. So we're going to go hunting for this 5. And the 5 comes from here. B plus 3 is going to be in front of x equals 5. So B equals 2. And that's what we got a minute ago anyway. It's just another way of doing it. Okay? So we'll try it this way. We'll go x squared plus bx. 10 divided by 2 is 5. Drop your x and 2 here. So that swings down here. Do 2b's. And 5 equals, what's it equal to? It's equal to this, 11. 2b equals 6. B equals 3. So the answer is x squared plus 3x plus 5. Now synthetic division will give us the same. Let's do that. 1, 5, 11 and 10. And we're using minus 2 as the root. There you go. 1 x squared, like here, 3x plus 5. So why would you ever need both of them? Well, if you do synthetic division here, you're going to end up using a third as the root, which is possible, but there's all sorts of tricks that I'm afraid it'll be too tricky for you at school maths. So when there's a number here, I suggest that you use my second method, my bx method. You say, fine, we'll drop that underneath. We'll divide the ends and do a bit of wishful thinking. Divide the ends, x squared. Divide the ends, minus 6. And wishful thinking, put in, pretend we know it when we don't know it yet. We don't know what b is. It's okay, we'll know it soon enough, won't we? We'll go 3x and 1. We'll do a double cross multiplication to get our x terms. It'll be minus 9. Let's do the b first. B minus 9 equals minus 19. B equals minus 1. Okay? Now I can show you that one with synthetic division, but it becomes b equals minus 1. I think that's the best way to do it. Okay, so here we have our answer here, except we're putting in minus 1 for b. We have x squared minus x minus 6 is the answer. Okay, let's see where we're going here with, have we done most of the difficult questions? This is set up for us. X squared 4 bx 2x 5 5b plus 8 equals negative 12. 5b, see, it's coming out nicely for us. Negative 20. B is negative 4. Okay. So we'll just come back and rewrite this. Negative 4 goes there. That's the answer. And so on and so forth. Leave it at that. You can do the rest as exercises. Do I even need to be careful here? I don't think I do. Now there could be one with no x. Here's one with no x. So this could be it. But it has an x, it's just a not x. Nah, I dropped it there. Let's get it back. So you should be able to problem solve your way through this question here I left you with. Let's do control home there, control end. So let's write it like this. Divide the ends. Multiply in the 2x plus 1 to our symbolic answer because it's got a b in it. We get 8 plus b is 0 because there's no x's here. So b is minus a. So that's not a problem. Okay, I'll post this to YouTube. And that's the end of it. Okay, thank you for watching and bye bye.